Yeah, so we'll be talking about how to build a stack for big data system, a generic stack. Obviously, the actual, am I audible? Yeah, obviously the actual compute and logic will depend upon your application, but I'll try to pull up things which are common to most or many of these systems. This is a bit about our company, branding stuff, and some intro about me. So we at PromptCloud kind of crawl and extract large scale data and we convert it into structured format. So what we do is we can give you data feed for all the mobile reviews on the web or all the travel data review in near real time. And we have appropriate feeds for that, and clients can connect to our API and they can get the data. This is the sample output, it doesn't really matter here. So we'll So this is the agenda of the talk. We'll set up the context that what we are going to cover in how deep. Obviously, each of these topics will take more than half an hour, and all taken together, we can't cover much. I'll just give a very high-level overview that what systems should be there, and what are the choices you have to make, and what are the key things to be taken care of. Then there are things which should have been covered in a longer lecture, maybe for a couple of hours, but we can't take that. Wherever it's mentioned here. Yeah, so if you build a system for big data, you will eventually end up with all this, multiple nodes in coherent set of coherent ones. What it means is you will have 10 servers which deal with DB related stuff, 14 servers which deals with job scheduling or one kind of job, and another 13 which deals with something else. And then compute layer where the actual processing logic lies, you will have multiple processes, quite often interdependent upon each other. What it means is, so probably output of one is eaten or processed by the some other process. So they have to communicate somehow, and more often than not, they'll be on different servers or different nodes. We'll have data storage layer and multiple middleware. Data storage is a critical component, and traditionally people had been using SQL-based storage layer. But with the advent of big data, it's not very easy to scale in that layer. Requirements, something like join and all, can't be easily made. It can be made in other systems also, but you make multiple trade-offs. So is consistency important? So how important is high availability? So those things come in storage layer and multiple middleware. Over there, we'll talk only about queues. So it's almost always present in these systems that multiple processes across the nodes, they talk via some messaging layer. Tools for installation, monitoring, and scheduling. These are pretty important actually. Once you have to, you operate on hundreds of servers or thousands of servers, people monitoring and managing them becomes a real pain. So unless you really think well about these things, systems become pretty painful pretty soon. There are other things which should have been covered, like source control, version control, code review, continuous integration, but they are not closely related. We'll leave them. Yeah, we'll start with, so the way I thought is, we'll start with how to install or what are the things to take care of when you try to build or install such systems. Then one or two examples from each layer, one messaging layer, one from storage layer, and then a sketch of a sample demo. We'll start with the installation. So simplest thing is you keep some image that this is our DB system image or this is queuing system image, and whenever you have to install one, you bring it up. Or if it's part of some cluster or cluster, then you add it by appropriate mechanism. Individual, this system is pretty good. There's no maintenance cost and it scales also. But main problem with that is how do you save back the changes. So let's say there's a system with some 10 custom software and you want to modify 2. So you have to make a new image and save it back. So tomorrow you may have to make small modification to something else. You again have to make a modification and save it back. So that doesn't scale. So tomorrow you will have same server version 3 and same server version 3.2.2. So and you will be confused what has to be used where. At the individual level, we have pretty robust and well-tested softwares like apt and yum, which work, and they work well for the individual system installation. So individual package installations. I don't know how many of you use etc keeper, but it kind of saves your config data in Git or some other version control system. So so these things work at individual machine level or individual package level. This works for one purpose, but if the purpose changes, this doesn't work. There's no way, or there's no apparent or easy way to scale this to multiple servers. What people do is they kind of write scripts to manually install Apache on Alt-N, and if you have to modify config file, then it becomes slightly painful. There's no silver bullet. This, if you really want to do it well, it's a difficult problem, and there are solutions for it which have been recently attempted. And Chef and Puppet, they are kind of popular choices, but how many of you have used one or both of these? Yeah, you will agree that it has pretty steep learning curve, and it has its own issues. But point is, once you set it up and the kind of things it promises, and these tools do them well. What about? Yeah, you could have put there, but I just picked two, and I'll talk only one. So before going further, I wanted to introduce something else. These things are difficult to get started, and pretty often you'll make mistakes. So rather than making mistakes on a real system, we kind of have something virtual, try out everything, and then if it works well, we replicate it on the servers. Many of you would have used VirtualBox on your laptops also. So it's pretty easy to install and download and install. And inside Debian you can run Ubuntu, or inside Ubuntu you can run something else. For all practical purposes, it gives you illusion of a real system, something like what EC2 does. So you can do it on your desktop also. Similar solutions exist for EC2, so cloud also, or servers also. For example, whole of EC2, there's a mistake, it's in EC2, is built using Gen. And then there's Vagrant, which is more of a wrapper around VirtualBox, and it allows you to configure VirtualBox in a headless way. You can do init, up, and SSH. So that these are three set of commands. And so it brings up the instance, and you can SSH inside that. For initial setting up purpose, these are two pretty useful things. So you can set a port forwarding. Let's say Apache runs on the port 80 of internal machine. You want to access it from external. So there's easy way to port forward from internal to external one. And also there's a provision for shared directory. So you can mark some directory as shared, and whatever you write in that directory goes inside the internal machine also. So you don't have to copy data between your machine and the virtual one. So out of those two, Chef and Puppet, I'm giving example of Chef. What it does is kind of basic idea behind this is they want to code the installation. So whatever you do in process of installing a new server, they want you to put that in code and goes in version control. So individual installation file will look pretty simple. So for example, to install a package Vim, we just say action equal to install, and it goes in some file. So this is the lowest part, and then there are things like which machine has which roles. So web server machine will have 3 softwares, and DB machine will have 4 softwares. We just have to name them that this machine has these roles, and when you run the Chef client, it installs those packages. So there's in simplest form, you can have Chef on your local machine also, and that's called Chef Solo. And if you want to have a centralized thing which kind of actually is needed for a large installation, then this tool can talk to the server and it gets all the data and metadata from there. And individual installation things, it's called cookbook, and that can be stored either locally or on the server. So I think in the first part we tried to cover how to install new softwares, or what are the tools of choice to install new software. Which softwares to install, it depends upon your application layer or logic. So next I'll take a few things from other layers like storage and messaging layer, and try to note down some points regarding those. What are things to take care? So first thing is, when you run multiple processes, there should be somebody to take care of those. You should know what's happening, how much memory it's taking. Do you want to kill it? Do you want to restart it? Do you want to kill it every 3 hours, or do you want to restart it whenever memory usage goes beyond a point? So again, I picked two tools, God and Monit. There could be others also, and we'll deal in some details about God. So this is a simple code snippet. I'll kind of skip over. Thing is, you can see which you can specify what command to use for start, what command to use for stop, and I don't know, it's not here. So yeah, you could have written things like if memory usage goes beyond 300 MB, restart it. So those things you can do. And once this God runs on a machine, you can remotely kill or restart the processes. Other is, once you have multiple processes running, it's no more feasible to manually schedule them or hard code their scheduling, because machine usage varies. And if you have multiple servers, more often than not, you'll be surprised if you kind of plot their usage or see the average usage, it's hardly ever more than 50%. So that's where something like job scheduler comes in picture, and it kinds of it allows you to utilize them in a better way. So again, there are many choices: rescue, beanstalk, celery, or in the simplest form, people use cron or some queues. Things to take care here is once you make choices or try to pick a new system for job scheduler, you should see if it has consideration for priorities, if it has consideration for tags. Priority is some jobs you want to run give more priority than others. It may be important, others can wait. Tags is this is something I really like. So a process can have multiple tags, so it's some host specific or it's some charset specific, and only some workers will run on them. Option for retry and ability to inspect the queues. So kind of each of these give 2 or 3 of these. They may not satisfy all the criteria. Data storage layer. So a lot of buzzword or a lot of articles you will see coming in this layer, because many things have been done. And the seminal paper by Amazon, I think it's called Dynamo or something, that really lays down the rules, and many of these systems kind of use that. So again, thing is, what's the thing you want to give priority to? So do you want to give priority to consistency, that if a data has been written, it should be written in all the replicated clusters, or do you want to give priority to availability, so that if data has to be written on 4 machines, even if it's written on 2 and 2 copy later, it's okay. Or what the use cases are, like is it a graph based system or is it a document based system? Do you want to handle your data at the level of documents, or do you want to handle at key value level? Key value, I guess most of us kind of misuse SQLite or MySQL to use key value. There are other systems which kind of do it at a distributed level. There are softwares for full text search. I guess Lucene and Solr are the most popular one. I'll briefly mention Voldemort, which is one of the popular key value stores. And this is the thing I wrote first. So in the long run, what happens in these software, that maintenance cost is more than it kind of outperforms anything else. So kind of amount of time you have to give to, let's just replicate the data. What happens if a node dies, which happens pretty often. So all those things should be considered. And with that respect, I really like Voldemort. So it's a simple key value store. It does only one thing and does it nicely. It's pretty simple to add a node or remove a node. You can specify if you want to write some data, how many nodes it should go to, and when you want to read, how many nodes it should be read from to be considered a valid data. So in the first part, we wrote that we saw that if there are multiple processes, they'll talk to each other, they'll be interdependent. So most common way to model this interdependency is to talk via some other layer. Quite often that happens to be the messaging layer. And if you see, compared to other things, I haven't written any choices here. So many people don't use RabbitMQ. I haven't understood yet why they don't use. Except for that, you have people in the team who is pretty familiar or is god of something else. But you should just use this. It implements AMQP. I guess it implements some other protocols also. Its Exchange server is pretty robust, so you can have models like direct, subscription, topic, or fan out. Direct is simple. I send message and you receive it. Nobody else knows. Fan out is it's kind of being broadcast to all the workers. And topic could be that a set of workers are interested in one thing. For example, if you try to model some BSc or NSC, you will have pretty often topic server will be used because there are many people who will be interested in stock prices of a company. It has good options for high availability. You can use DRBD or pacemaker, and it has been well tested. Many people have used it, and it hardly ever fails. There is one catch though. You should not try to use DRBD. DRBD is disk level replication across the machines. You should not try to use it on Amazon or EC2 because that itself is a virtual layer and you don't want to do disk replication on a virtual layer. So I guess these were the components I want to talk about, and I had sketch for a demo which I can't do. So simple demo we could have done is we could have individual workers could have generated Markov sentences randomly, and we could have stored them in a Voldemort store, which would be globally available, and other set of workers which would be kind of waiting for the new job. After storing this, we could have included these in RabbitMQ or some other job scheduler, and other set of workers could have worked there. So, but this is a kind of cheating. So, basic cheating comes here is there is no interdependence in the processing of those records. They are individually processed. That makes the thing simpler. If there is interconnection between those records, then modeling such system becomes difficult. But this demo I can't show you because my laptop doesn't work. There are other things which could have been part of this talk, but yeah, I'm almost done. But I didn't add in detail because of lack of time. So thing is, on this level, you need a monitoring system for alert and dashboards. Otherwise, again, you will have no idea. So in monitoring system, I'll just talk about Sensu and Graphite. So Sensu, you can think of it as a routing layer. So each of your individual processes, they send some data, they send some report, they send some logs to Sensu, and it decides what to do with it. So it can send that to Twitter, it can send that to your IM message, it can send that to PagerDuty. Or if it's something like time series data, you can send that to some graphic engine like Graphite. So that will make a graph and you can see something blew up or something is being utilized at low level. There was one more thing, if you kind of try to build or if you design such a system, you should take care is distributed log collection. Again, I think one of the speakers today in this series talked about Splunk and there. So that I'll leave. Other is Flow and Scribe. And these things can be used for multiple things. Their common requirement or common goal of these tools is to aggregate data from multiple processes. So it can be used to route logs or aggregate logs. It can be used simply to move data from one system to another. So some points about Flume, it allows multiple tokens. So there's a source of data which happens to be multiple nodes or multiple processes, and there's a sink. You may want to store this in HBase, you may want to store this in SDFS or somewhere else. And how the data goes from source to sink is specified by topologies. So that kind of you have to design that which servers are loaded or which you want to put primarily for log redirects. I guess that's all. It was pretty fast and I didn't go in deep of anything because we could not have done. So each of these will take more than half an hour. I'll be available here today as well as tomorrow. We can talk if